Hello students, this is first lecture for chapter number 4 and the name of chapter is coordinate geometry. Coordinate geometry is made up of two words, coordinates and geometry. What is coordinate? Coordinate means a point on the xy plane. If say for example I make x and y axis here, this is x axis, this is y axis. So we are talking about point, any point on the xy plane, and any point is marked by xy. How it is marked? If we draw a perpendicular here, clear? So this distance is x and this distance is y, then it is marked as xy. Clear? This is one thing. Another thing I want to tell you about the coordinate axis. If this is the coordinate axis, clear? This is very important point that you need to remember. This is known as first quadrant. This is known as second quadrant. This is known as third quadrant, and this is known as fourth quadrant. And in this quadrant, x is positive, y is positive. So both coordinate will be positive. Both the x and y value will be positive. But here x will be negative, y will be positive. Here both will be negative in third quadrant. And here x will positive but y will negative. These four things you need to remember, because you must be aware where x is positive, where y is positive. Because I want to tell you this side x is always positive, and this side x is negative. This side, clear? Here this is positive, clear? But here this is negative. Similarly, above y is positive and below y is negative. So you need to act accordingly. Okay. If we come to another point, geometry. Geometry is a study of straight lines and circles. So in this chapter, we are going to study about the straight lines and the circles. But before we start the study of straight lines and circle, we need to study a very important point, namely symmetry. Symmetry means what? Symmetry means image. And image means what? Is a mirror image. Clear? So, in simple words, if I want to say the symmetry, what is this? This is A for apple. This is A for apple. So, can we find a line that can divide this A into two parts? Two same part? Yes, this is the line. If you see, if this is the mirror, if I mark a mirror here, clear? So this is what? This is because this line, this red line is dividing this A into two same parts, clear? So this is called axis of symmetry. Symmetry. And you can call it mirror also. Clear? So this is the point, this is the line that is dividing this A into two parts. Clear? So this is called axis of symmetry. So we need to find axis of symmetry of various English alphabets. If we take B, so is there any axis of symmetry exist? Yes, this is axis of symmetry because it is dividing B into two same parts. Clear? This is the line. C. Now if we come to D, so is there any line where we can get the mirror image? Yes, D is here. And about E, this is the line. Above and below same. Clear? But there are English alphabets. A symmetrical, opposite vertical line. Be symmetrical about horizontal line, horizontal line, horizontal line, horizontal line. But it is neither symmetrical about vertical line horizontal line, neither symmetrical about the horizontal line. So this is not symmetrical. This is not symmetrical. Clear? So in this topic, we are going to find a line that divide the given graph into two same symmetrically opposite part. Clear? Symmetry. Okay, move to the next page. Symmetry is of three types. Symmetry can be divided into three types. Number one, symmetry with respect to x-axis. Number two, symmetry with respect to y-axis. And the third one is symmetry about symmetry with respect to origin. So these are the three types of symmetry. Clear? So we will define one by one symmetry, and then parallelly we will study examples on that. Okay, so we are going to study case 1. Case 1 means symmetry with respect to x-axis. This is the first type of symmetry. So here we should learn it how we are going to do it. Clear? First of all, I will define this. What is a symmetry with respect to x-axis? A graph is said to be symmetric with respect to x-axis if xy, this is the coordinate, xy is on the graph. If xy is on the graph, then x minus y should also on the graph. That means if a point xy is on the graph, x minus y should also be on the graph. Okay, this is one thing. Another definition is if replace y by minus y, clear, and no change in the equation, then the graph is symmetrical with respect to x-axis. These are the two things and both are same. Clear? Here we are saying if we replace y by minus y. Yes, here we are replacing y by minus y. Same thing. Clear? If we want to see one example, if this is the x-axis, clear, and this is the y-axis. So where is xy? Xy is here. This is xy because positive. We are talking about positive. And where is minus x minus y? Here. X minus y is here. That means if some graph is in first quadrant, same graph should be in fourth quadrant. This is, it should be like that. Means if it is above, it should be below also, because this point, this coordinate is in the first quadrant is xy, and here is x minus y. So like this one. So first of all, we will study some question example one, and we will study. I will draw a graph here, and you need to tell me whether this graph is symmetrical about x-axis or not symmetrical about x-axis. Clear? So you can see, clear, whatever it is above, it is same below. Means x-axis should act like a mirror. Since in this x-axis is working like a mirror, so this is symmetrical about x-axis. Now we will take another graph. It should be same above and below x-axis. If it is same, it is symmetrical about x-axis, otherwise not symmetrical about x-axis. This is, and this is. It's symmetrical? Yes, it is symmetrical. Why? Because x-axis is working like a mirror. It is same above x and same below x. This is the second one. And if we want to draw another curve also, like y-axis, x-axis, is this symmetrical about x-axis? Yes. Why? Because x-axis is working like a mirror. It is same above x-axis, same below x-axis. And one more I will take, like this one. It is x-axis, it is y-axis. If we draw this graph and this graph, is it symmetrical about x-axis? No, because it is given above x-axis but below there is nothing. So x-axis is not working like a mirror. So it is not symmetrical about x-axis. Clear? You need to remember all these things. This is one type of question. Now if we move to another type of question, clear? Check whether following curve are symmetrical with respect to x-axis. Clear? So there will be curve, like the curve is x equal to y power 2. So we need to check whether this curve is symmetrical about x-axis or not. So how we check it? Change y by minus y. Clear? So x equal to, what we are doing? We are changing y by minus y. So this is minus y power 2 is minus y times minus y. And if we do it minus minus plus, y into y is y power 2. So you can see the equation here, x is equal to y power 2, and the equation here, x is equal to y power 2. They are same, no change. Okay, so symmetrical with respect to x-axis. Okay, this is the solution. If we take another curve like x power 2 plus y power 2 is equal to 2x. If we take it, then same thing, change y by minus y. So it will be x power 2 plus minus y power 2 is equal to 2x. So x power 2, and what it will be minus y power 2? It will be y power 2 is equal to 2x. So you can see what equation was given. After changing, we are getting the same equation. There is no change. No change. Same. So symmetrical with respect to x-axis. This is second type of question. What is third type of question we may have here? Here, plot the point on xy plane. Means we will give you a point. You need to plot the point on the xy plane. Also, find another point that is symmetrical to x-axis. So you need to do in this question 2 points. One point is you need to plot the point on xy. Okay, let us say the point number 1 is 3, 5. If 3, 5 we are taking the point, so let us draw it on xy plane. This is x-axis and this is y-axis. Okay, so 3, 1, 2, 3, both are positive. 1, 2, 3, 4, 5. So it will be here. This point is 3, 5. Clear? So this is the first point. Mark the point, plot the point on xy plane. So we plot it. It is here. It is 3 distance on x-axis, 5 distance on y-axis, like this one. Now you need to find another point that is symmetrical to x-axis. And how we are getting a point symmetrical to x-axis? Replacing y by minus y. So changing 5 by minus 5. So it is minus 1, minus 2, minus 3, minus 4, minus 5. It will be here. This point is 3, minus 5. So these 2 points are symmetrical towards x-axis because it is 5 unit above x-axis, it is 5 unit below x-axis. So it is symmetrical about x-axis. Okay. Now we will take another point. Let us take 3, minus 5. Okay, first mark this point on xy plane. This is x and this is y. So 3. Oh, 3, minus 5. It will be same to same. No, we will not take this. We will take some another point because it is same. So let us take minus 3 and 5. Minus 3 and 5. Okay, where will be minus 3? It is x negative side. 1, 2, 3. This is minus 3, 5. It will 1, 2, 3, 4, 5. So it is here. This point is minus 3, 5. So this is the plot. Okay. Now you need to find the symmetrical. So we change y only. We do not change x. We change only y. So 5 will be minus 5. So 1, 2, 3, 4, 5. It is. We are not changing x. We are changing only y. So minus 3, minus 5 is the symmetrical point with respect to x-axis. So there are two things. If you want to plot, if positive, move this side, x positive side, this side. Negative, move negative side. Y positive, up. Y negative, down. And mark the point. If you want to find symmetrical with respect to x-axis, just change y the value of y by minus of it. If it is negative, change in positive. If it is positive, change in negative. So these are the three type of questions in case of symmetry. Now, case 2. Case 2 is symmetry with respect to y-axis. Symmetry with respect to y-axis. So how to find the symmetry with respect to y-axis? This is number 1 definition. A graph is said to be symmetric with respect to y-axis if xy and minus xy points are on the graph. That means if xy point is on the graph, minus xy point should also be on the graph. That means symmetry about y-axis, we are changing x. Clear? So if replace means change, replace x by minus x and no change in the equation. Then the graph is symmetrical about y-axis. So my dear friends, like in the symmetry about x-axis we are changing y, now here we will change x. So if this is the point, this is the x-axis and this is y-axis. Clear? And here this is point xy. This is point xy. So minus x means x opposite side. This is here. Minus x, y should be on the graph. So if this is the graph like this one, these are the points, then these points should also be on the graph. It will be like this one. So in this case, y-axis will work like a mirror. Clear? This will be axis of symmetry and it will work like a mirror. These are the two things. Okay? Axis of symmetry and mirror. Now the same three type of questions we will have. So question number 1, we will take some of the graphs. So if we take the first graph, this is x-axis and this is y-axis. Clear? So how it is? Now the graph should be, y-axis should work like a mirror. Clear? So if we make like means if I am making a graph like this one. Clear? So there should be this one. Then it is symmetrical about y-axis because y-axis is working like a mirror. Number 2. This is y-axis. If I'm making some graph like this one. Yes, because you can check xy. xy point is there and minus xy point is there. You can check xy point is there and minus x y point is there. Clear? So yes, this is symmetrical. Now we'll take the third example. Y. Y means if we make a graph like this one, and if we make a graph like this one, is it symmetrical about y-axis? No, it is not symmetrical about y-axis. Why it is not symmetrical about y-axis? Because here it is graph, here is no graph. Here it is graph, but here is no graph. So y-axis symmetrical is not possible in this case. So this is symmetrical, this is symmetrical, this is not symmetrical. So cross it. Okay, so this is first type of question. Second type of question is what we are going to do. We will check whether the curves are symmetrical about y-axis. Okay, so how to check it? It is question number 1 here. It is y is equal to x square. This is the first graph. Y is equal to x square. So change x by minus x. About x-axis we change y. About y-axis we change x. So y equals to minus x power 2. So y equals to minus x times minus x. So if you multiply it, minus minus plus x into x is x power 2. Now you can check both places y is equal to x square. Both places y is equal to x square. So because no change, so symmetrical about y-axis. And if we take the same question like previous type of symmetry, x power 2 plus y power 2 is equal to 2x. So change x by minus x. So it will be minus x power 2 plus y power 2 is equal to 2 into minus x. Minus x power 2 is x power 2 plus y power 2 is equal to 2 minus x is minus 2x. Now you can see here this equation and this equation, and this is change. This is changed. Why changed? Because here 2x is positive, here 2x is negative. So this is changed. Not symmetrical. Not symmetrical about y-axis. Not symmetrical about y-axis. Clear? So if you want to check a curve is symmetrical or not symmetrical about any particular axis, you need to change x and y accordingly. If the curve remains unchanged, then it is symmetrical. If it is changed, it is not symmetrical. Now third type of example, it is plot the point on xy plane and draw a symmetrical point. With respect to y-axis. y-axis. Okay, so let us take a point 2 minus 5. This is the point. We are taking the point 2 minus 5, and 2 minus 5, let us draw this x-axis, this y-axis, 2, 1, 2. Draw y-axis, minus 1, minus 2, minus 3, minus 4, minus 5. So this point, this is 2 minus 5. So this is how we plot the point. Move x distance, then move y distance, and then mark the point. Okay. Now, if you mark the point symmetrical to it, what you need to change? You need to change x by minus x. So minus 2, minus 1, minus 2. It is here. This is minus 2, minus 5. You can see y is not changed. Only x is changed because it is symmetrical about y-axis. Okay. So now let us take 0 minus 4. 0 minus 4 means this is x-axis and this is y-axis. So 0 means here, this intersection point. And minus 4 means y minus 4. Minus 1, minus 2, minus 3, minus 4. So this point is 0 minus 4. This is the point. 0 minus 4. Okay. Now you need to find a symmetrical point towards x, y-axis. Means we need to change x by minus x. Oh, here x is 0. So you write 0 plus 0 minus 0. The meaning is same. So this is, what is the symmetrical point to 0 minus 4? It is 0 minus 4. No change. Here because it is a non-zero number, so it changed to minus 2. Symmetrical point becomes minus 2, minus 5. But here because this is 0, so there is no change. 0 minus 4 will remain the same symmetrical point towards y-axis. Okay. Now the last and third type of symmetry, it is case 3. Symmetry with respect to origin. Symmetry with respect to origin. So here we will talk about whether the symmetry is about the x-axis, y-axis or origin. So now we are in third point. A graph is, this is the first definition, a graph is said to be symmetric with respect to origin. A graph is said to be symmetric with respect to origin if x, y and minus x minus y. Means about x-axis we were changing y. Clear? Y by minus y. About x-axis, about y-axis we were changing x. But about origin we are changing both x and y both. If xy and minus x minus y are on the given graph. So if these 2 points xy and minus x minus y both are on the given graph. Number 2. If replacing x by minus x, y by minus y, the equation do not change, then it is symmetrical about or with respect to origin. This is clear. So if we see here, this is x-axis, this is y-axis. So if this is the point x, y, then minus x minus y should be there. Clear? So in this type of symmetry, you need to look whatever the image in first quadrant, same should be in third quadrant, and whatever in second quadrant, same should be in fourth quadrant. If it is like that, then the graph is symmetrical about the origin. Clear? So for example, you can see the first type of question, it is the x-axis, the y-axis. This is the circle. Clear? So you mark a point. Here is what point? X, y. Here is what point? Minus x, minus y. So both changing. Here is what point? It is minus x, comma y. And here is what point? X, comma minus y. Minus x changing plus, plus changing into minus y. So all points are on the coordinate plane. Clear? This is xy plane or coordinate plane. Both are same name. So whatever image in the first, same it is in third. Whatever image in the second, same image in the fourth quadrant. So it is symmetrical about origin. Okay. Now number 2, there is one more graph is there, that is symmetrical about origin. Oh, look, if this is the graph and this is the graph, clear? This is whatever is in first quadrant, same is in third quadrant, clear? And if we mark a balloon here like this one, this is the balloon, and if I mark a balloon here, this is the balloon, then it is symmetrical about origin, because whatever is in the first, same is in third, and whatever is in second, same is in fourth. So this graph is symmetrical about origin. This is about origin, this is about origin. Okay. So because in these x and y both are changing. If somebody asks you whether the second type of question, if we take, so what it is? Replace. No. Check whether the following curves are symmetrical with respect to origin. So let us take the first curve. It is a circle. So x square plus y square is equal to a square. This is the equation. This is the equation of circle. We will learn in the coming lectures. Okay, so change x by minus x, y by minus y. Both we are changing because we are checking with respect to origin. So minus x power 2 plus minus y power 2 is equal to a power 2. Minus x power 2 is x power 2. Minus y power 2 is y power 2. And it is a power 2. So you can see this graph and this graph, both graph are same to same. This graph and this graph, both graph are same to same. Because both graph are same to same. So what it is? No change in equation. Same equation. No change in equation. So what we can say? Symmetrical with respect to origin. Clear? Another curve we will take, it is x is equal to 1 upon y, or this can be written as xy is equal to 1. It is both way. You write it x is equal to 1 upon y, or you write it y is equal to 1 upon x, or you write it xy is equal to 1. All the three graphs are same graph. Clear? So what we are doing? Changing x by minus x and y by minus y. So minus x minus y equal to 1. Minus minus plus. So xy is equal to 1. You can see both are same. So same. Same means symmetrical with respect to origin. Clear? This is the second type of question. And if we want to mark the third type of question here, what it is? Plot and find a symmetrical point about or with respect to origin. So let us take a point. It is say 4 minus 3. The point is 4 minus 3. So first we need to plot this point on xy plane. 4 minus 3. This is y. 4. 1, 2, 3, 4. Minus 3. Minus 1, minus 2, minus 3. So this is the point. 4 minus 3. And how to get the symmetrical point about origin? We are checking about origin. So how to get with respect to origin? Replace 4 by minus 4 and 3 by minus 3. So minus minus plus. So it will be minus 4 3. Because we are changing here x and y both. So plus 4 is positive. So change negative. 3 is negative. So change positive. So it is minus 4. So minus 1, minus 2, minus 3, minus 4. Clear? But 3 changing into positive. 1, 2, 3. So this is the point. This is the point minus 4, 3. So here you can see because this point was in fourth quadrant, the same point we get in second quadrant. Understand? So here first and third quadrant you need to notice, second and fourth quadrant you need to notice. Okay, so similarly we can solve another, we can consider another points and find the symmetrical about the origin. Now the last question, it is question number 3 given in your course material. Question number 3 over page 121. This is, what is the question? Question is a graph is given. So first we are going to do it about x-axis. Clear? What is the graph? Graph is given. This is x-axis. This is y-axis. And here a line is there. And this is there. What you need to? You need to extend. You need to extend this graph with respect to x-axis. Means we need to form another part of this graph so that it becomes with respect to x-axis. So when it happens, if this x-axis will work like a symmetrical about with respect to x-axis. Clear? Symmetrical about x-axis means what? Y should be same. With respect to Y, we are making it wrong because symmetrical about x-axis means Y should be changed. Clear? So y-axis should work like a image. This one. Clear? When it will work like a image y-axis, that if this line is here, this should be here. This is okay. And if this line is here, it should be here. This is. So it is symmetrical about x-axis. X-axis means, no, I explained it wrong. This is symmetry about y-axis. This is symmetry about y-axis I formed. This is about y-axis, please. Okay. And if we take about the x-axis, so it will be what? This is x-axis. This is x, this is y, and the same graph. This is and this is. You need to extend it symmetrical about x-axis. So x-axis means it should be below and above same. So this is working symmetrical about x-axis. This was about y-axis. Okay, here above x and below x same. Here left side of y, right side of y should be same. Clear? It is about x-axis. Now about origin. About origin, how I explained you? I told you whatever is in the first quadrant, same will be in third quadrant, and whatever is in second quadrant, same will be in fourth quadrant. This you need to make it. Okay. So this and this is the graph. Now you extend it towards the symmetrical about origin. Origin means, now look, first quadrant it is a circle. So same will be in third quadrant. Here this is the line in second quadrant. Same will be in fourth quadrant. This is. So this graph is symmetrical now up with respect to origin. So what they can ask you, they can give you some graph like they have given here, this graph. You need to extend this graph with respect to x-axis, with respect to y-axis, with respect to origin. With respect means so that now you can see it is symmetrical about y-axis, yes. It is symmetrical about x-axis, yes. It is symmetrical about origin, yes. Because whatever here we are changing x by minus x. You can see x by minus x. Whatever x positive side, same is negative side. Here we changing y by minus y. It is above y is positive, below y is negative. And here x by minus x and y by minus y. This is. So that's all, my dear friends, about the symmetry. Thank you very much.